Hi, and welcome to another mini lecture on pre-calculus. Today we are going to talk about transforming the graph of a natural exponential function and finding its domain and range. So here we are looking at the function exponential of x whose graph is drawn here, and we want to make some transformation to this function. For example, minus exponential of x minus 3. And then we want to find the domain and range of the same thing. Here's another example, just exponential of minus x plus 4. The tools that we are given, there is this pen tool that you can use to drag your graph to the left or right or up or down. You can reflect it across the y-axis and you can reflect it across the x-axis. So the idea here is to quickly get to the picture by making some transformations to the picture. Before we go into that, let me just say a few words about this number e, and then we come to the graphing itself. Other than e being a number that's not a whole number, the steps that we're going to take here are very similar to what we have done in the previous section. So what is e? Uh, You can simply go with the fact that e is just a number. Its approximate value is 2.71828, etc. And then you can go ahead and just do the graphing and such with that. But the question here is, what is so special about this number that has a letter named after itself, and why are we interested in that? Well, in mathematics there are a set of numbers that are very important. They show up in a variety of contexts. You already know about the number pi from high school. Pi 3 point and so on. It has been with humanity since several thousand years ago. It has a simple description. Pi is the ratio of the circumference of a circle to the diameter of that circle. So this is the ratio of circumference to diameter. For number e, nobody has a simple picture like this to explain what e is. I just write a few descriptions of number e, and then you have to wait until your calculus class to see more detail on this. We are going to have a chance to explain some of this later on in the context of word problems related to exponential growth and decay and interest rate calculations. But right now, let's just briefly say a few words about the number e. One way to describe e is the following series: 1 plus 1 over 1 plus 1 over 1 times 2 plus 1 over 1 times 2 times 3, and so on we go. Okay, so this summation never stops, which just keeps adding, and this one, if you calculate it, comes close to this number quickly. Another way to explain number e, you will see again this in calculus, where you are going to be introduced to the concept of limit, is the limit of 1 plus 1 over x to the power of x as x tends toward infinity. Now what does that mean? Again, I'm going to briefly mention this thing. You don't need all this detail right now, but just so that e doesn't look like as a mysterious item here, if you make a table, on one side we are just going to have x as usual, and on the other side we are going to have our formula, 1 over 1 plus x to the power of x. Now we want to let x go to infinity. How can we do that? Many ways. Here's a way of quickly going to that direction: 1, 10, 100, 1000, and so on. Every time take a jump by a factor of 10, so I'll have I take these x's and put it in my formula. Well, the first one is very easy. Well, it's just 2. Now, what if instead of that I put 10? To raise the power of 10, you need your calculator. And if you calculate it, you get something like 2.59, etc. We are coming close to the number that we are targeting here. Now, if you go use a higher number, you come closer. 1 plus 1 over 100 to the power of 100. That turns out to be almost 2.70. If you go to 1,000 to the power of 1,000, this almost becomes 2.71, etc. The idea here is that if you go toward infinity, this right hand column is going to go to number e, which is just a shorthand for 2.71828, and so on it goes. Sometimes called the Eulerian number, sometimes the base of natural logarithm, and so on, a variety of names. If you're wondering why would anybody come across a description like this, we are going to actually see this thing shortly in the context of interest rate calculations. For example, as you go and buy a home, hopefully someday, and then you have to pay installments. The calculation of installments is going to use a formula very similar to the formula that we have here, and in fact motivation for the study of E came from actually interest rate calculations. Okay, so that was a brief description of what E was. Again, it's just a number between 2 and 3 that's enough to get us started. Now, what happens here? We explained this in the previous lecture, but it's a good idea to go look at it again. Let me draw it here. So suppose I want to graph, I have exponential of e to the x. I want to know what to do to get the graph of minus exponential of minus, oh, excuse me, it's just x, I guess. So let's double check, make sure it was just x. Yes, x minus 3, sorry. X minus 3. I want to graph this function. So what are two modifications? This is modification number 1. This is modification number 2. So what does minus do? So let's go step by step. Suppose I want to graph minus exponential of x. Exponential of x itself is given to me. Multiplying it by minus simply makes it flip upside down. All the y's are going to be negative of what they were before, so that makes the picture go upside down. Well, how do you make your picture flip? Well, that's how you make it to go upside down. And then step 2, what do we want to do? We want to subtract 3 from our function. So what does that how is that going to be done? Subtracting 3 from a graph that you already have is same as dragging it down by 3 units. Well, the one problem with the exponential is that it's kind of a slippery curve. There is no handle on it, there's no specific point to pick on, but here is one favorite point to look at, easy point. That's the point 0, 1. At 0, this is 1. So when you flip it, of course it has come to that's 0 minus 1. So you can take that point and drag it down. Other points are going to be kind of hard because you're using this number e and it's not a whole number. But here, if you were at minus 1, if you drag it down to minus 4, so it was minus 1, you want to lower it by 3 units, then your graph is going to come here. Now all aspects of the graph are going to move with it in special line is the asymptote. Exponential has a horizontal asymptote. When you lower the exponential, then the asymptote of it is also going to come down. So this was at y equal to 0, just the x-axis. When you lower it, it's going to come to here, come to line y is equal to minus 3. Okay, so this is the asymptote. If they ask for it, what else they ask for here? Well, they ask for the domain and the range. Domain, same as before, all x's for which you have a value for the function. So at any x, I can find where the function is at. It's like looking for a roof or a floor, if you wish. So if this was like the bottom of the ocean, you could go all the way to the minus infinity to plus infinity, and you are going to hit the bottom somewhere. So the domain is the set of all x's that are acceptable for our function, and here every x is acceptable. No number is going to prevent you from calculating exponential of x. Next, well, how about the range? Range is set of y values that we get. Well, how do you calculate the y values? You come and say, okay, here is my y-axis. For example, is there any point on the function whose y matches this? Well, no. If I go to left or right, I don't hit my graph anywhere. If I go left and right, I don't hit the function. So I draw a horizontal line wherever that if that horizontal line hits the graph, means that point is in the range. But none of these things are on the range. Well, what is in the range? For example, here's I'm in the range. Here I'm in the range. Why am I in the range? Because I hit the picture. Here I hit the picture, and so on. So how about the minus 3 itself? Do I hit the picture if I go exactly at minus 3? Well, it just misses the function by a hair. This function never reaches to minus 3. So minus 3 is still not in the range. So all of these are not in range, and starting from here going all the way down, these are in the range. So the range, we start from the lowest, from minus infinity is in the range, to minus 3, but not the minus 3 itself. They are all in the range. Okay, so that was a quick way of graphing this thing without graphing it point by point. We called that last time as a brute force style of graphing. If all fails, you can always go to that to get a rough picture and then form your final answer around that. But now the idea is to use this quick method. So here we used a flip across the x-axis, then we drag it according to the number that is given to us, and the asymptote moves alongside with it. Here's another example, exponential of minus x plus 4. So I have y is equal to exponential of minus x plus 4. So again, we are starting from our base function exponential of x that hopefully we know it has a graph like 2 to the x or 3 to the x that all look like each other. This is just one in that family of the functions. That's a graph of exponential of x. First, we pay attention to the following. What does this minus do here? Changing x's to minus x's, it simply means you're flipping the picture across the y-axis. So this is the graph of exponential of minus x. So what do? Again, you use this flipping mechanism. It flips it left to right, right to left, it flips across the y-axis. Once you are done with that, then you say, okay, I take this thing and I want to drag it. Which way is it going to go? Plus 4 means we are going to go up by 4. Well, the points on this graph are kind of hard to get, but the this point, right, the y-intercept is easy because at the point 0, 1, it's easy to look at. So if you take that and drag that one 4 units, so 1, so by now you come to 2, 3, so by the time you're done, you're going to be at 0. We come up by 4, so by now we are at 5. So your graph now is going to look like this. Again, it asks for domain and range. Let me draw this thing better. So this doesn't, the asymptote of it is going to be y is equal to 4, because the old asymptote is going to come up with everything else in the function is going to come up by 4 units, so it's going to come to y equal to 4. So can you say quickly what is the domain and range? Domain of this, again, all x's are fine, so we go all the way from minus infinity to infinity. How about the range? The range of this, well, it starts at all points above 4. So it starts at 4 and goes all the way to plus infinity. Okay, so that's how these type of graphings are done. So what did we do again? We described E. For full description, wait for your calculus. Every now and then we are going to remind ourselves of this number E. Just you know that it is this particular number you're done. It's somewhere between 2 and 3, closer to 3 than it is to 2. Okay, what does the graph of it look like? The graph of it, as you see here, is just like the graph of 2 to the x or 3 to the x and any of those functions. We are making modifications. Either function is multiplied by a minus or the x is multiplied by a minus. If the minus is in front of e to the x, we are flipping upside down or flip across the x-axis. If the minus is in front of x, we are flipping left to right, and in that case we are using the other flipping mechanism. Adding or subtracting is going to drag our function up or down by that amount, and then the asymptote also moves up or down by the same. The asymptote of exponential of x by itself is y equal to 0. The new asymptote is going to be according to the number you are adding or subtracting. Okay, until our next mini lecture, good luck and God bless.